All right, so continuing on with lesson 7.3, I want you to go ahead and solve these problems. So number 6, a little bit more algebra, and then 7 through 9, you are telling me which theorem allows you to say that yes, this is indeed a parallelogram. So of those 4 that we learned in that last lesson, which one allows you to say that it is a parallelogram? Go ahead, pause the video, and write down your thoughts. All right, so in number 6, you could do this a couple different ways. So I just picked to solve for x first by default. Doesn't really matter. You could solve for y first if you'd like. So setting my opposite angles, A and C, equal to one another, because it is a parallelogram, or we're trying to say that it is. Solving for x, I get x is 32. Now, you could set up the similar way and set 4y equal to y plus 87. Or maybe you're thinking about this a little different. If you substitute x back in, that means angle C is 64 degrees. Well, in order to be a parallelogram, these two angles must add up to 180 degrees because they're supplementary, right? We learned that in lesson 7.2. Well, I've already used 64 degrees of my 180, so 180 minus 64 is 116. And then I would have this extra 87, so subtract that off, I would get y is 29. Again, you could have chosen to set 4y equal to y plus 87. Subtract y, you get 3y equals 87. Divide by 3, you still get y equals 29. So it doesn't really matter which route you go. Do what makes the most sense to you. All right, on number 7, we got to think about what information are we given. Well, here we know that it's 30 and 30, so they're congruent, and we got those arrows signifying that it's parallel. So it's the opposite sides, parallel, I used a shortcut there, and congruent theorem. I'm running out of room. Number 8, we can see the opposite sides are congruent, 7 and 7, 5 and 5. So it is the parallelogram opposite sides converse, because we're concluding that it's a parallelogram. And then the last one, we can see the opposite angles, 65 and 65, 115 and 115 are congruent. So it's the parallelogram opposite angles converse. Again, it is the converse because we are concluding that it's a parallelogram. We're not given that, we're concluding it. All right, you got this next one. Go ahead, do number 10 with the algebra, and then I'm going to talk through number 11. All right, so doing our algebra, setting them equal to one another, we solve and we get that x is 2. Now we can double check ourselves by substituting that back in. 2 times 2 is 4. 10 minus 3 times 2, well 3 times 2 is 6. 10 minus 6 is also 4. Therefore our diagonals are congruent, so that makes it a parallelogram. Now on number 11, we got options. And I'm going to tell you, some are easier than others. But you can pick whichever one makes the most sense to you. On this shape here, we can choose our 4 different ways to prove that it's congruent. Option 1, we can show that the opposite sides are congruent. Therefore, we'd have to do the distance formula for BC and AD, show that they're equal, and do the distance formula for AB and DC, show that they're equal. That's doing the distance formula 4 times. I don't know about you, but I don't want to do it 4 times. So our other option is show that the opposite angles are congruent. Well, I'm going to guess you don't have a protractor at home, so that one's out. Option number 3, we could show that the diagonals bisect each other or cross at the midpoint. We don't even have diagonals drawn in. I don't know the length of my diagonals. Then I would have to find the length of their midpoint. No thanks. Seems a little bit too long. So the most efficient or the fastest way is to pick one set of sides and prove that they are the same length and that they're parallel, that opposite sides parallel and congruent theorem. So it doesn't matter which 2 sides you choose. I'm going to choose A, B, and C, D, just because, doesn't matter. Well, looking at A to B, I'm going up 2 and to the right 5. So the slope of AB is 2/5. And then looking from D to C, I'm going up 2 to the right 5. So the slope is also 2/5. Well, same slope means those 2 lines are parallel. Okay, not bad. We did part of it. But now you have to do the distance formula. And I'm going to have you pause the video here and you do the distance formula from A to B and from D to C. Go ahead, leave it in radical form. No need to get a decimal. All right, on both of those, you should have gotten the square root of 29. So AB and DC both have a length of square root of 29. Now, we've shown that they're parallel. We've shown that they are congruent to one another. So these two are congruent. Therefore, by the opposite sides, parallel and congruence theorem, this must be a parallelogram. Now, there's one more example that I want you to do, and I want you to try this one totally on your own. It's going to be similar to some that you have in your homework. So go ahead and pause the video. Now, I chose to do the left and the right sides, JK and LM. You could have picked the top and bottom. It doesn't matter, and I actually showed the top and bottom in yellow. But sticking with the left and the right side, we can see that the slope for both of them is -6/1 because we're going down 6 to the right 1. So the slopes are the same. That means those two lines are parallel. And then using the distance formula, the lengths of both of them are the square root of 37. So those two segments are congruent. Therefore, by the opposite sides parallel and congruent theorem, we got ourselves a parallelogram. Now, like I said, if you chose the top and the bottom, you can see the slopes here are both 2/6, or that reduces to 1/3. And if you found the length of both of those, they would both be the square root of 40. So they're congruent by the same theorem, opposite sides, parallel and congruent. It's still a parallelogram. It doesn't matter. You just pick one set. All right, that's a wrap for lesson 7.3. So you can now go ahead and do the homework.